Lecture 58, Science Behind Common Phenomena. Welcome to Unusual Science, where we unravel the extraordinary in the seemingly ordinary. I'm your host, and today we embark on a journey through the veiled mysteries of everyday phenomena. Have you ever paused to question the enigmatic blue canvas stretched above us? Or pondered the mystifying spark that leaps from your fingertip to a doorknob? The world around us pulses with scientific secrets hiding in plain sight, whispering their truths to those curious enough to listen. In the next 20 minutes, we'll peel back the veil on 5 captivating phenomena that surround us daily, yet whose inner workings remain shrouded in mystery for many. Let's begin with perhaps the most overlooked wonder of all our azure sky. The endless blue expanse above has inspired poets and philosophers since time immemorial, but its scientific explanation is no less enchanting than any verse or contemplation. The sky's mesmerizing blue hue emerges from an elegant dance between sunlight and our atmosphere. When sunlight, which appears white but contains all colors of the visible spectrum, enters our atmosphere, it collides with gas molecules. This collision, known as Rayleigh scattering, occurs when light interacts with particles much smaller than its wavelength. Here lies the baffling secret. Blue light has a shorter wavelength than red light, causing it to scatter more readily. As sunlight journeys through our atmosphere, blue wavelengths scatter in all directions, creating the azure dome that blankets our world. But this same phenomenon unlocks another mystery, the fiery hues of sunset. As the sun sinks toward the horizon, its light must traverse more atmosphere to reach your eyes. The increased atmospheric journey filters out the scattered blue light, allowing the longer red and orange wavelengths to dominate the canvas of our evening sky. Next time you gaze upward, remember, you're witnessing light waves dancing with atmospheric molecules in a performance that has captivated humanity for millennia. Now, let's illuminate the perplexing phenomenon of static electricity. The mysterious spark that jumps between your finger and a doorknob after shuffling across carpet holds secrets of atomic proportion. This seemingly magical occurrence stems from the imbalance of electric charges, an invisible force that permeates our world. When two different materials make contact, electrons can transfer from one surface to another. Some materials cling to electrons more tenaciously than others, a property we call the triboelectric effect. As you walk across carpet, each step creates friction between your shoes and the floor. The carpet, being electron-hungry, pulls electrons from your body, leaving you positively charged. This invisible imbalance persists until you approach a conductor like a metal doorknob. The enigmatic spark you experience is nature seeking equilibrium electrons leaping through air to restore balance. This miniature lightning bolt can reach thousands of volts, though carries minimal current. Intriguingly, this same principle manifests on a grander scale in the atmosphere, where storm clouds become charged through collisions between ice and water droplets, eventually unleashing lightning, static electricity's most dramatic expression. Let's arc toward another captivating phenomenon, the rainbow. These enchanting spectral bridges appear like magical portals after rainfall, yet their formation follows precise optical principles. The rainbow's mystery begins with the interplay between sunlight and raindrops suspended in moist air. Each raindrop becomes a miniature prism. When sunlight enters a raindrop, it slows and bends, a process called refraction. Different wavelengths of light bend at slightly different angles, causing white light to separate into its component colors. The light then reflects off the back surface of the raindrop and refracts again as it exits, creating the dispersion pattern we perceive as a rainbow. The mesmerizing arc always appears opposite the sun from your vantage point, with red on the outer edge and violet inside. Even more baffling are double rainbows, where light reflects twice inside each raindrop, creating a secondary bow with reversed color order. Notice how the sky between primary and secondary rainbows appears darker. This enigmatic band is called Alexander's dark band, named after Alexander of Aphrodisias, who first described it in 200 CE. Each observer sees their own unique rainbow, formed by different raindrops depending on their exact position, a personal spectacle crafted by light, water, and perspective. Now, let's ascend to the mysterious realm of clouds and fog. These ethereal formations that drift across our skies or shroud our early mornings in mystery share a common scientific origin. Both clouds and fog materialize when water vapor. An invisible gas transforms into visible water droplets through condensation. This transmutation requires cooling air and condensation nuclei, microscopic particles like dust, salt, or pollution that provide surfaces for water vapor to condense upon. Clouds form when warm air rises, expands, and cools, causing invisible water vapor to condense around these floating particles. The bewildering variety of cloud shapes, from towering cumulonimbus to wispy cirrus, stems from different atmospheric conditions. Fog, though seemingly distinct, is merely a cloud that forms near the ground. It materializes when moist air contacts a cooler surface, or when warm rain falls through cool air. The enigmatic morning mists that transform landscapes into ethereal realms occur when nocturnal cooling brings air temperature to its dew point. Perhaps most perplexing is radiation fog, which forms on clear nights as the ground rapidly loses heat, cooling the air directly above it and creating those haunting blankets of white that dissolve with the morning sun. Finally, let's plunge into the mysterious bubbles of boiling water. The dancing bubbles that emerge when water boils conceal fascinating physics that few pause to consider. Contrary to common belief, the first bubbles that appear in heating water aren't water vapor, but dissolved gases being forced out of solution. As water warms, its capacity to hold dissolved gases diminishes, causing oxygen and nitrogen to form bubbles that rise to the surface. These initial bubbles appear well before the water reaches boiling point. True boiling begins at the water's boiling point, 100 degrees C at sea level, when liquid water molecules gain enough energy to escape into the gaseous state. These vapor bubbles form at nucleation sites, microscopic scratches, or imperfections in the container. The mesmerizing rolling boil occurs as vapor bubbles grow and detach from these nucleation points, rising through the liquid. This explains the baffling observation that water boils more vigorously in an old, scratched pot than in a perfectly smooth one. Even more intriguing is how pressure affects this dance of molecules. At higher altitudes where atmospheric pressure is lower, water boils at lower temperatures, a mysterious phenomenon that transforms cooking in mountainous regions. As we conclude our exploration of these everyday marvels, I invite you to look again at the world around you. The universe has encoded scientific wonders in the most commonplace experiences, from the cerulean sky above to the roiling kettle on your stovetop. Understanding these phenomena doesn't diminish their beauty, but rather enhances our appreciation of nature's elegant solutions. Next time you encounter static electricity, witness a rainbow, or watch water boil, pause to appreciate the hidden complexities unfolding before you. In the seemingly mundane lies the truly extraordinary, waiting for the curious mind to uncover its secrets. In our next lecture, we'll explore the fascinating world of everyday chemistry, discovering how molecular interactions shape our daily experiences. Until then, I encourage you to observe the world with renewed wonder. Look up at the sky, notice the morning fog, and witness the small miracles that surround us all. For in understanding these common phenomena, we glimpse the intricate tapestry of natural laws that govern our universe. Thank you for joining me on this journey through the science of everyday marvels. Until next time, keep questioning the commonplace, for therein lies the truly extraordinary.